Okay, we will pick up right where we left off. Remember, tank, inflow, mixing, outflow, Q is the amount, dQ dt is the rate of change with respect to time. I set up this equation using just the idea of grams per minute coming in and grams per minute going out, right? Because those are the only two things affecting this. There's nothing else affecting the amount in here. And I set up that equation. And then I got this guy, which simplified down to this, and then I moved this over and I said, oh snap, I can use integrating factor. So let's jump into the integrating factor part of it. Mu is equal to e to the integral of p of t dt, where p of t is 1 over 50. So that is e to the integral of 1 over 50 dt, which is a simple integral to do. It just gives me e to the 1 over 50t. I like to work with fractions in here instead of decimals, but it's up to you what you want to do. So now I'm going to multiply everything by this. So I get e to the 1 over 50t q prime plus 1 over 50 times e to the 1 over 50t times q. I multiplied this whole side by my mu is equal to 20 e to the 1 over 50t. Now, before I go any further, let's go look at this thing and think practically about what is going to happen, because that's always good to do. If I can think practically, then I can verify my results to see if they make sense. So, I start with 3 grams per liter, right? And then I keep that 100 gallons or 100 liters the whole time, and I have an inflow of 10 grams per liter. So as time goes on and more water flows through here, the concentration of this is going to approach the concentration of what's coming into it. This is going to take over, right? So as long as that 10 stays consistent, right? So if you got 10 grams per liter, 1,000 liters, what should we have at the end, right? Sorry, 100 liters. I sort of said the answer. 100 liters at 10 grams per liter. Each liter has 10 grams. Well, we should have 1,000 grams. So it's good to think about that, to check, because most of these problems make sense in that way, in one way or another. Okay, so now let's check our derivatives. Q derives to Q prime. This, does it derive to this? And it does. You should see that. I get a little chain rule there. It works perfectly. So that's good. Thumbs up. From here, I've got e to the 1 over 50t times q prime, just like we've been doing, equals 20 e to the 1 over 50t. Now I can integrate both sides. Left side just undoes that prime, so I get e to the 1 over 50t times q equals, when I integrate this, I get 20, but then I multiply by 1 over 150, so that's the same as 50 times e, that's because of chain rule, or u sub, to the 1 over 50t. That gives me e to the 1 over 50t times q equals, that gives me 1,000 e to the 1 over 50t. So, boom, don't forget your plus c. All right, so here's where I'm going to solve for my plus c. Now, let me go back up. Talked about this quite a while ago. But remember, q of 0, I figured out, well, if I've got 100 liters and each liter has 3 grams, then I can multiply by like this using dimensional analysis and get that q of 0 is 300 grams. So that's what I'm going to use here. I'm going to say q of 0 is, actually, do it up here. So what that gives me is, right here I have an e to the 0, so that's 1. So I get 1 times q, that's that 300 right there. So 1 times 300 equals 1,000 times e to the 0 is going to be 1 plus a constant. So really I've got 300 equals 1,000 plus c. So that means that c is 300 minus 1,000, so negative 700. So let me rewrite this one more time. E to the 1 over 50t q is equal to 1,000 e to the 1 over 50t minus 700. So last step here is just to divide by the e to the 1 over 50. E to the 1 over 50t. What that gives me is q equals, when I divide it out here, I'm just left with my 1,000 minus 700. And in this case, I think it makes a lot of sense to write e to the negative 1 over 50t. Now, that's my function. That is it, right? That gives me the amount of salt in this thing right here. And we're going to increase the complexity, and you can imagine, like, you know, I could do all kinds of crazy stuff with this application-wise. So let's talk about why this makes sense. And I'll do that in a moment. Brought this thing back down. Now, some of these things I've actually already talked about, you know. I said that this, you know, should approach, the concentration of this as time goes on should actually approach this 10 gallon or grams per liter. So, and then also, it better have that 3 grams per liter in the beginning. Let me find Q of 0 given this. Well, look, 1,000 minus 700 e to the 0. That just gives me 1,000 minus 700, which is 300, which matches up with what we've talked about. Also, I can double check that. 300, if I have 300 grams, remember that those are my units here, and I divide it by the volume of that thing, then that gives me 300 over 100, 3 grams per liter. It matches that. Let's look at the limit as t goes to infinity of Q of t. So this, I'm not going to show much work. I'll just say it out loud. All right, look, this is exponential decay, right? So if I were to, like, quote, plug in infinity right here, then I would get e to the negative infinity. What? Yes, there are lots of q's. You like the q's? Okay, good. So I get e to the negative infinity. That would go to 0, right? Which means that this whole term, right? So that I get an exponential decay here as t goes to infinity. That means this whole term goes away. So what's the limit as q goes to infinity? Well, it's just 1,000 minus nothing, which is 1,000. Why does that make sense? Well, once again, the volume in this one doesn't change. It stays at 100 liters. So if I were to find the concentration as time goes on, or as time goes to infinity, then I would do 1,000 over 1,000 grams, because this is grams, over 100 liters. Boom, boom. I get 10 grams per liter. That should make total sense. Why does that make total sense? Because that is the concentration of the thing that's coming in. So it should make sense that, it should make sense that this thing's concentration approaches the concentration of the inflow, because that is that constant 10. Anyway, hopefully this makes sense. And I think I'm going to give you one more example that is a little bit more complicated, and that will be in another video. Goodbye. Thanks. Thanks for your patience through this. I appreciate it.